another way or a shortcut that how actually we can do that without having any sweat. So what does that mean? It means that right now I'm going to still, the theory is there, is I would like a shortcut that is going to help me to do the polynomial division, but only when the divisor is a simple linear factor or it's x minus c. As you just remember, we could do that with anything. But right now I'm going to show you a way that if by exception, most of the time this by exception, if you're talking about this at least level of algebra, if I do have some kind of exception and the number that I'm going to divide by that is just the fact that the power of 1 is just about some kind of linear number, I can use this technique or this trick. So why we are trying to use that? We are trying to be faster, again, some kind of, it has a less prone to sign errors, and there it's going to directly connect us to the remainder and factor problems itself. So again, remember the divisor must be this form of x minus c. So for instance, if you do have x plus 2, we are going to consider the c as negative 2. If you do have x minus 5, we're going to consider c as 5, and I will show you how. Imagine that we do have the same question. So I do have 2x to the power 3x2, negative 5x plus 1, and I would like to divide it by x minus 1. So how I can do that? We are only going to work with the coefficients and c itself. It's x minus c, so c is going to be 1. Check. I do have 2 over here. I do have 3 over here. I do have negative 5 over here. And I do have the 1 itself over here. So right now I'm going to do that. So it is so like the dividing a number by another number, but it has a little steps. It's going to be a little bit different and also a little bit challenging. So try to memorize the steps. Let's see all of those steps. What we should do right now, the very first thing that we have to do is to bring down the first number. I'm going to bring down the 2. So I'm going to move it like this one. I'm going to keep the 2. After that, I'm going to multiply and add. What does that mean? I'm going to multiply the number that I put down over here by the divisor, multiply it by it, and after that, I'm going to add it up with my second number and write down another number. I'm going to do the same thing. 5 multiplied by 1 is going to be 5, and adding with the second number, 0. Multiply 0 by 1, which is obviously 0, and add with the last number, which is going to give me 1. The final number is my remainder. The first number is going to be the power of my first factor. As you guys remember, the factor should be 1 less than the whole thing, because obviously I do have the power of 1. So this should be power of 2 in order to add this 2 up, and we do have the power of 3. So I do have 2x to the power 2. I do have 5x, and I do have 0. So I do have x minus 1, just like the way it was. I have 2x to the power 2 plus 5x, and I do have 1. This is just like the way that we did, somehow a little bit more challenging like the last one, but at this point, at this level, at least we know we're not going to face any sign problem, we're not going to face any coefficient problems, and still we're going to have the same number. But remember, you only can do this way, or you only can do these some kind of shortcuts while your divisor is going to be the power of 1, x minus 1, x plus 1. And also make sure when you have x minus c, means that the number beside should has a negative sign beside of that. For instance, if you had x plus 5, actually it was x minus negative 5. So your c is going to be negative 5 itself. So be very careful about that. After that, we are going to see that we talked about this kind of remainder, and we talked about the factor and how actually we are going to use that, because yes, we found out that I can convert the long polynomial to the combination of two terms multiplied by each other, and I do have a remainder. Sometimes yes, sometimes I don't. So how I can use it actually in the real function or in the real graphing? So let's see what is going to happen. The theory, or some kind of the behind the story over here, is that when I do have the polynomial, which is the log f of x, and if I divide that one by x minus c, the remainder would be f of c, just like the way that we had for the last example. So we can find the remainder of a division just by plugging a number into the function. What does that mean? It means that instead of just doing everything that we just did before, we can use the x, for example, if it was x minus 2, we can just plug x2 is equals to 2 inside the f of x, and we can find the remainder. For instance, at this point, or at this some kind of example, imagine that they're asking for x minus 1, and we are looking for the final number. right? Instead of just doing all of this mumbling and jumbling thing, we can do what? We can find the f of 1. So 2 times 1 to the power 3 is 2, plus 3 minus 5 plus 1. If you do this calculation, what you got, 1 is going to be the remainder. Bam, that's it. So how we can find some kind of the factor? The rule would say that x minus c is going to be a factor of f of x if and only if my f of c is going to be 0. This is just like the way that we have with quadratic equation. If you remember, at one point we were trying to have the rooting function. The rooting function means that I either going to have two roots, one root, or no root at all. So what the root means, it means that if I use x, or by the substitution method, if I just get rid of x and use that specific number, inside of that my f of that specific number is going to be 0, and that is the main definition of root that I had. So at this point I also can use it. So let's some kind of have the practical application just before talking about the whole function itself. So I do have the suspect, x minus x to the power 3 subtracted by 4x2. I do have x and plus 6. The question is x is equals to a factor? Instead of just doing all of those divisions, yes, still I can do and find the remainder and etc. The only thing that you can do right now to know that actually is minus 2 is a factor or not is just make x as 2, put it inside the f of x, and see that you are going to 0 or not. If that was a 0, yes, thumbs up, that's a factor. If it wasn't the 0, it could give you negative or positive, thumbs down, that's not a factor itself. So let's see what is happening. So at this point, I have to move my x, and instead of that, I have to add 2 to the power 3, negative 4, 2 to the power 2, plus 6, and after that, I have to find something. If I do this calculation, 0. So I know for a fact that f of 2 is going to be 0, and the remainder of that guy is 0. Therefore, x minus 2 is going to be a factor. How I can use that? If I would like to write down my polynomial into some kind of the terms that it could be multiplied by each other, I know for a fact that x minus 2 is a good one. So I can divide this guy by x minus 2, and I can find other related numbers and without any remainder. So I don't have any problem with that, right? It is going to be some kind of help before drawing all of the function, before reaching to that kind of specific level itself. So let's talk about it. Let's talk about the case that actually we are going to use all of these things in order to see that is it going to be applicable or not. So at this point, I do have the suspect. I do have my f of x is x to the power 3 subtracted by 4x2 plus x plus c. And I would like to see, first of all, the behavior itself. You see that the degree is 3. It's odd. And some kind of leading coefficient is 1. So I know for a fact the left goes down and right again goes up. So I don't know anything about this one. This guy is just like the black box to me. But I know left goes down and right goes up. This is a fact. After that, I have to find the zeros. From the previous slide, as we just saw, x minus 2 is going to be a factor, right? So I know for a fact that if I divide this guy by x minus 2, based on the way that I know, the remainder is 0, and I can find other things. How we could do that? If you guys remember from the trick that we learned, 1, negative 4, 1, and 6. We are going to divide that by what? We are going to divide that our x minus c. The c is 2. We are going to do something like this. Move 1 to the down. After that, multiply by 2. And after that, what we should add it with negative 4. We do have negative 2. Negative 2 multiplied by 2, negative 4, added with this one, negative 4. Is going to be negative 3. Negative 3 multiplied by 2, added with this one, negative 6. So obviously the remainder is 0. Kind of another term is negative 3, negative 2, and 1. So it would be x to the power 2 subtracted by 2x subtracted by 3. Simple as that. So right now I just wrote down my long term like this one. After that, I also know another fact from my quadratic equation that x to the power 2 subtracted by 2x minus 3 equals 0. I obviously is going to have some roots. How I know obviously going to have some roots? If you remember from the formula I gave you, that x1 and x2 is equals negative b plus minus roots of b to the power 2 subtracted by 4ac divided by 2a. If I know for a fact that the number, some kind of beside that square root is going to be positive, for a fact I do have two roots. Let's just find the delta and let's see that's going to be applicable or it's going to be right or not. So how I can do that? My delta was, it is x2 plus bx plus c, right? My delta was b2 subtracted by 4ac. If you do that, you have 4 subtracted by negative 3 times 1. And obviously it should be multiplied out times by 4 itself. So this guy is going to be 16. So delta is bigger than 0. For a fact, I do have 2 roots. How can I find 2 roots? It's the x1 is negative b plus root of 16, the delta divided by 2a, and x2 the same thing subtracted by square root of 16 2a. So if you do that, you do have this one. It's still, and right now you can make your work, or you can make your factors even simpler. So I do have x plus 1, I do have x plus 1, I found it over here. X minus 3, I found it over here, and you have x minus 2, which was found from the fact that x minus or 2 is the factor. So I know this guy is going to have 3 interceptions with x-axis. The very first one, negative 1. After that is 2, and after that is 3. But it is somehow right now and have some ambiguity that what is happening over here. How this guy knows that 0 and 6 is going to be interception with y-axis? Simple. As I just told you, the only thing that you have to do, either look at your remainder, looking at the final number, which is going to be the 6 itself, or just find f of 0. If you just find f of 0, you're still going to have 6. It means that 0 and 6 is going to be your whole point, and you just draw the thing that you like. Simple as that. So what would happen over here if you do have another some kind of example? So sorry about that one. Apparently some kind of the final drawing, the function that we had has a problem still, so I had to some kind of change it. So let's look at the question. I do have the suspect that my g of x is negative half times x minus 1 to the power 2 times x plus 2 to the power 2. First of all, let's look at the degrees, and the leading coefficient is smaller, is going to be negative, okay? Degree is 2, and another 2 degree is 4. So what do I have? I do have even degree, and I do have negative coefficient. It means that both ends down, and it is going to be something like this. Both sides goes down, right? So let's look at it. So another thing that we can see from this side is that what is happening between them, right? I do have x minus 1 to the power 2. It means that the root of 1 and multiplicity of 2, root of negative 2 and multiplicity of 2. So x2 equals to 1, multiplicity of 2, and x is going to negative 2, and is going to be 2. It means that we do have some kind of touching, and after that changing in the behavior itself. So what is happening at x is equals to negative 2, I do have touching, just like this one. And as x is equals to 1, still do have touching. It means that this guy was decreasing, had some touching, decreasing, and after that this part is going to increase a little bit, and still are going to have increasing. So maybe some of you would ask, okay, how can I find this point? As I just told you, the only thing that you have to do, put f of 0. If you just find f of 0, you can find the interception with y-axis, and as simple as that is going to be negative 2 itself. So all in all, there's some kind of whole idea of this work was how we can deal with polynomial. What was polynomial? Polynomial means that you have to deal with x's, but your x's are not going to be normal, like the linear or the quadratic again. They are going to be some kind of bigger number, 3, 4, maybe more than that. The only thing that we covered was from 1 to 4. This is going to that you need to right now at part of the some kind of, say, intermediate or advanced algebra. And after that, how we can find the factors, how we can some division. If I do have a condition and specific condition that there's a long division, it's going to be this, long polynomial is going to be divided by x minus c. I can use a trick rather than just using the normal way, which is absolutely right. I can use a trick, and I can draw that by knowing the fact about the multiplicity, about the degrees, about the touching, and all of those parts. Try to some kind of rewatch this video to completely understand it about the polynomial, and try to also answer this question. This is going to be another question that I put it for you. Again, it's a degree of 4, and right now some kind of your mission is just find the factoring and do a couple of things over here. This one is going to be a little bit simpler because you already know for a fact that x is going to be one of your factor, and x equals 0 is one of your factor. It's going to be a little bit simpler, and try to work with that. Try to pause the video, work with that one, make sure that you completely understand it, and after that try to some kind of rewatch the whole video and make sure that you can solve the final answer. Try to put the comment for me down below if you have any kind of problem. I will get back to you, or if I couldn't, I'm probably going to make another video, some kind of only examples for you guys to completely understand everything. Again, my name is Mahmoud Kiasari. Thank you for being here today with me. Have a super great day, night, whatever. See you around.